Hi student, welcome to this new video still on Laplace transform. Our focus this day is the inverse Laplace transform. Remember that we define the Laplace transform as a transform integral that convert a function of real-time t to a function of complex variable s. Therefore, the inverse Laplace transform will be the transformation of the Laplace transform into a function of time t. Given that Laplace transform of f of t equals to f of s, right? Therefore, f of t is considered as the inverse Laplace transform of f of s, and it is written as f of t equals to the inverse of the Laplace transform of f of s. Now, this is a very important notion for you to grasp and understand. In most cases, you will make use of the Laplace transform table to find the inverse Laplace transform of standard Laplace transform function. For instance, if I'm looking for the Laplace transform of 1 over s, if I'm looking at the inverse of the Laplace transform of 1 over s, from the Laplace transform table, it's obvious, it will be 1, right? If I'm looking for the inverse of the Laplace transform of 1 over s minus a, from the Laplace transform table, it's easy. I can easily find the corresponding function of t that corresponds to the Laplace transform function. It will be exponential et. Now, it is important for you also to understand that in most cases, you won't have standard Laplace function as given in the table. You have to apply some manipulation to have standard Laplace function in such that you can easily use the Laplace transform table. Now, the next thing to touch in this video is to speak about the linearity of the inverse Laplace transform. As it was in the case of the Laplace transform, the inverse Laplace transform also conserves the linearity. That is, the inverse Laplace transform of f of s a plus b g of s, f of s being the Laplace transform of f of t, and g of s being the Laplace transform of g of t, a and b be constant. This will give that is a inverse of f of s plus b inverse of g of g of s. It's easy, right? Now, and also the second theorem that we can also see here is the first shift theorem. As we saw previously in the Laplace transform, it will have similar application also on the inverse Laplace transform, in such that if you have that f of s is the Laplace transform of f of t, then, and you have that s superior to a and superior to 0, then you have that the inverse, right, of f of s minus a will be equals to f of t times exponential t. Now, these are the two main properties of the inverse Laplace transform, and those can be used to solve practical questions. So let's have a look on some examples. Find the inverse Laplace transform of minus 2 over s. Now, how do I find such a inverse? When I look minus 2 over s and I check in my Laplace transform table, I realize that this is not a standard Laplace transform that I can find directly from the table. So I have to apply some manipulations in such a way that I should have the standard form easily, then I can have the inverse. So this will be equal to, applying the linearity property, I remove minus 2, then I have minus 1 over s, right? And I know that the the inverse of 1 over s reading from the Laplace transform table is equal to 1. So I have minus 2 times 1, which equals to minus 2. Now, second example, find the Laplace transform, the inverse of 5 over 2s minus 3. Okay, so when I look at this, I realize that 5 over 2s minus 3 is not in the Laplace transform table. So I have to apply again some manipulation here in such a way that I can have a standard function as given in the Laplace transform table. So here I see that I can have the denominator to be expressed as s minus a, right? So I will divide the denominator by 2, right? And then this will give me the inverse of 5 over 2 divided by s minus 3 divided by 2, right? And this, apply the linearity, this will give you 5 over 2 times the inverse of the Laplace transform of 1 over s minus 3 over 2. Now, if you check your table, you will realize that in your table, you will see that the Laplace transform of EAT is 1s minus a. So I can quickly see that from this here, by identification, my a will be minus 3 over 2. So the inverse will be a function of exponential. So it will be 5 over 2 times exponential 3 over 2t. So the Laplace transform, the inverse Laplace transform of 5 to s minus 3 equals to 5 over 2 times exponential 3 over 2t. Okay. This video clearly explained to you what the inverse of the Laplace transform is. You saw the definition and the major properties that are involved in the inverse Laplace transform and how you can use them to solve practical questions. In the next video, we will touch on more deeper practical example to give you a better understanding of this concept. Thank you.